Good morning, my dear children.
Good morning, ma'am.
Good morning. Good morning. So, what about the symbols of elements? Did you learn the symbols of elements? Yeah.
Ma'am, you told homework.
Find out the origin of a symbol of gold and silver, right?
Yes, ma'am.
Yeah. Then, Handana, you can tell me from which word this symbol AU that came for gold?
Ma'am, Aurum.
Yeah, it's from Oram. Okay. Then what about silver? Anyone? Silver. Other than Nandana.
Argentum.
Yeah, very
Ma'am,
good.
Argentum.
Yeah, it's Argentum, right? Okay. So gold from Oram, that is AU. Then silver from Argentum. That's why it's AG. Okay. Okay, children. Again, please pitch on your videos. Helen. Yeah. Anjana, Hritvik, Suryadev. Okay, so I'm just going to ask the symbols of elements. Okay, symbols of elements. So at Leo, can you tell me the symbol of silver?
AG.
Yeah, it's AG. Then Tamanna, what about gold? Tamanna? Yes. Network issues? Okay, Suryadev?
Ma'am.
Gold, gold. Symbol of gold.
Ma'am, AU.
Yeah, it's AU. Then Sridev? What about uranium?
U.
Yeah, it's U. Then Alan, iodine. I. Hira, bromine.
Ma'am, BR.
Br. Anandida, barium.
BA.
Yeah. Then Amin, cobalt.
Yes, ma'am. CO.
CO. Then Fadil, lead.
Ma'am, PB.
Yeah, Pb. So I think you all revised well, right? About the symbols of elements. Now we are moving to next topic. That's about atomic mass. Okay, atomic mass. What do you mean by atomic mass? How can you define this atomic mass?
And the mass of the atoms.
Yeah, mass of an atom of element. That is known as atomic mass. Okay. So in this topic, we will learn how can we determine the atomic mass of elements, and we will learn the atomic mass of very few elements. Okay, children. Then before moving to that, what about your assignment? Did you start it?
Yes, ma'am.
Yes, right. So you have to remember the last date of submission, that is September 15th. Okay. Yes. So we are moving to the topic atomic mass. Atomic mass. So before learning the atomic mass of different elements, we are going to learn how this atomic mass came. Okay, how this atomic mass came. So this Dalton's atomic theory proposed the idea of atomic mass, which explained the law of constant proportion. In the law of constant proportion, we have learned that the few elements that combined in a compound, they are combined together in a fixed proportion by mass, right? That's according to law of constant proportion or law of definite proportion. Do you remember, children? Do you remember the law of constant proportion? Anyone, can you please state the law of constant proportion? Yes.
In a chemical substance, elements are always present.
Present in a chemical compound, elements
Definite
are
proportion.
yeah, always combined by definite proportion by mass, right? Here, according to this law of constant proportion, he proposed the idea of atomic mass. Okay, so the mass of an atom of an element, it is called its atomic mass. The mass of an atom of its element is called its atomic mass. So hydrogen is an element, right? So this atom of hydrogen, it has its own atomic mass. Oxygen atom, it has its own atomic mass. So all elements in the periodic table, they have their own atomic mass. So the determining mass of an individual atom, it was a relatively difficult task. Relative atomic mass was determined. So to find out the atomic mass of each and every element in the periodic table, it was very difficult. It's a difficult task. So here we are using the method relative atomic mass. Okay, relative atomic mass. That means we will fix the atomic mass of one element and all other elements atomic mass is related to this fixed mass. Clear? Okay, we will we will find out the atomic mass of one element and we will relate all the atomic mass of other elements with this reference. Clear, children? So here determining mass of an individual atom, it was relatively difficult task because after different procedures and different experiments, we can able to find out the atomic mass. You know that in a periodic table, more than 100 elements are there, right? So it will be very difficult to find out the atomic masses of all elements in the periodic table. So here we will determine or find out the atomic mass of one element and compare the atomic mass of all other elements with this value. Okay, clear, children? That's the method of relative atomic mass. Relative means it can be compared or related with a fixed mass. So this atomic mass unit, it is abbreviated as AMU. Its short form AMU, small letter. So its full form is atomic mass unit. Okay, AMU, that's its short form. That is atomic mass unit. Atomic mass unit. Atomic mass unit. But nowadays we are using another term for this atomic mass unit, that is unified mass. And it can be represented as small letter U. Unified mass, it's small letter U. So this Dalton's atomic theory proposed the idea of atomic mass, which explained in the law of constant proportion. So the mass of an atom of an element is called its atomic mass. Determining mass of an individual atom, it was a relatively difficult task. So here we are using relative atomic mass method. And the atomic mass unit, it is abbreviated as AMU. AMU. Nowadays, it will written as unified mass and its symbol is U. Okay. This is clear, children? Yes or no? Yes, tell me. Yes, okay. Jairus, can you please read the slide?
Atomic mass. Dalton's atomic theory proposed the idea of atomic mass, which explained the law of constant proportions so well.
Yeah.
The mass of an atom of an element is called its atomic mass. Determining mass of an individual atom was relatively difficult task. Relative atomic mass was determined. Yeah. Atomic mass unit, abbreviated as AMU earlier, now written as unified mass U.
Yeah, it's unified mass U. Okay, unified mass U. Suryadev, Tamanna, Uzza, Nigila, switch on your videos. Atleo, Hritvik, Anjana. Lakshmi Nandakumar, can you please read the slide once again? Lakshmi?
Yes, ma'am.
Yes, switch on your videos, children.
Dalton's atomic theory proposed the idea of atomic mass, which explained the law of constant proportion so well.
Yeah.
The mass of an atom of an element is called its atomic mass.
Yes.
Determining mass of an individual atom was a relatively difficult task. Relative atomic mass was determined.
Yes.
Atomic mass unit, abbreviated as AMU earlier, and now it is written as unified mass, U.
U, right? Have you completed the slide, children?
Yes, ma'am.
All of you, right? Okay, then we are moving to the next slide. So next we are going to fix the atomic mass of one element. I told you we will identify the atomic mass of one element, right? Then we will relate the atomic mass of all other elements with this reference. So while searching for various atomic mass unit, scientists initially took 1/16th of the mass of an atom of naturally occurring oxygen. So first scientists identified that 1/16th mass of oxygen, it is considered as one atomic mass unit. Okay, 1/16th. 1/16th mass of oxygen. That is fixed as the atomic mass unit or one atomic mass. Clear, children? While searching for various atomic mass unit, scientists initially took 1/16th mass of an atom of naturally occurring oxygen as the unit. And the two reasons for selecting this oxygen reacted with a large number of elements and formed compounds. That's the first reason. Oxygen reacted with a large number of elements and formed compounds. In the periodic table, this oxygen will react with almost elements. That's why they are selected oxygen. And the second reason for the selection of oxygen, this atomic mass unit give mass of most of the elements as whole numbers. When we are selecting this oxygen's 1/16th mass as one atomic mass unit, the atomic mass of all other elements will be in whole numbers, not as decimals. Okay, it's in the form of whole numbers. Okay, so due to these two reasons, initially scientists selected 1/16th mass of an atom of naturally occurring oxygen as the reference. Okay, clear, children? I will repeat it once again. While searching for various atomic mass units, scientists selected or they initially took 1/16th. That means when we are considering this mass of oxygen as 16, that means one part of that 16. Okay, it is considered as the atomic mass unit. And the two reasons for selecting oxygen, the first reason is that oxygen reacted with a large number of elements to form compounds. Oxygen reacted with a large number of elements to form compounds. And the second reason is that when we are selecting this oxygen as the reference, all atomic masses of elements, it will be as whole numbers. Whole numbers. Okay. So due to these two reasons, they selected oxygen atom. So Fadil, can you please read the slide?
Yes, ma'am.
Yeah.
While searching for various atomic mass unit, scientists initially took 1/16th of the mass of an atom of naturally occurring oxygen as the unit.
Yes.
Reasons. Oxygen reacted with a large number of elements and formed compounds.
Yes.
Second reason, this atomic mass unit give mass of most of the elements as whole numbers.
Okay, whole numbers. Now, Neet, can you please repeat it once again?
Yes, ma'am. While searching for various atomic mass units, scientists initially took 1/16th of the mass of an atomic of naturally occurring oxygen as the unit. Reasons.
Atom of naturally occurring oxygen as the unit. Okay.
Unit. Reasons. First one, oxygen reacted with a large number of elements and formed compounds. Second reason, this atomic mass unit give mass of most of the elements as whole numbers.
Okay. Have you completed, children? The slide? All of you?
No, ma'am.
Yes or no? No. Nandana? Okay, okay. You can complete it.
Ma'am, completed.
Completed. Shall I move to next one?
Yes, ma'am.
So you have to remember the first selection of scientists regarding the atomic mass, that is oxygen. Okay. So later in 1961, okay, in 1961, IUPAC. What's the full form of IUPAC? Do you remember, children?
International Unit of Chemistry Unit of
Pure and applied science. Chemistry.
Hmm.
Pure and applied chemistry.
Once again, international, then
U
International Union of Pure and Applied Chemistry.
yeah, that's it. International Union of Pure and Applied Chemistry. Okay, that's the full form of IUPAC. They are the organization that will provide names and symbols for all the elements in the periodic table. Okay, so this IUPAC, International Union of Pure and Applied Chemistry, they have accepted atomic mass unit U, carbon 12 isotope was chosen as the standard reference for measuring atomic masses. Initially, scientists took oxygen as the reference, but later carbon 12 isotope is chosen as the standard reference for measuring atomic masses. What is this isotope? Isotope. Any idea? Children?
The top of C12 written.
Once again?
Carbon, when we say carbon's atomic mass, we can see about this simple 12.
Yeah. That we will learn in next chapter about this isotope. But now you have to just remember, 1 minute, children. Okay. So isotope, that means you know that different elements are there in the periodic table, right? They have their own atomic number, isn't it? Hydrogen, it's 1, oxygen 8, then helium 2, lithium 3, like that. Similarly, they have mass number. Okay, they have mass number. So in this nature, we can obtain these all elements in different isotopic forms. Different isotopic form means they have same atomic number and the same element, but their mass number will be different. Okay, mass number will be different. Sometimes we will obtain the carbon with mass number 12. Sometimes it will be 13. Sometimes it will be 14. Their atomic number always, in the case of carbon, it's 6. But the difference in their mass number. Sometimes carbon 12. That means their mass number is 12. Then carbon 13. That is their mass number is 13. Then carbon 14. Their mass number is 14. Okay, so different mass numbers of elements will be obtained from nature. So here, this carbon 12 isotope was chosen as the standard reference. That means their mass number is 12. It can be obtained from nature with the atomic number 6 and their mass number is 12. It is considered as the standard reference for measuring atomic masses. So we will fix the atomic mass of carbon 12. We will find out the mass of carbon 12. Then we will find out the atomic masses of other elements using this carbon 12 as the reference. Clear? Clear, children? Yes or no?
Yes, ma'am.
Yes. So the atomic mass unit, it is defined as the quantity of mass. Okay. One atomic mass unit, that is equal to the mass, that is equal to 1/12th of mass of an atom of carbon 12. It is equal to 1/12th mass of an atom of carbon 12. If the mass of carbon, it is considered as 12, then 1/12. If there are 12 parts, the one part of that 12 parts, it is considered as the atomic mass unit. Clear, children? The atomic mass unit, it is defined as the quantity of mass equal to 1/12th of mass of an atom of carbon 12. First we took oxygen and there we are considering 1/16th of oxygen. Later they will fix the carbon 12 isotope as the standard reference and the 1/12th mass of an carbon atom, it will be considered as the atomic mass unit. So 1 AMU or U, that is equal to 1/12 into mass of an atom of carbon 12. And that value is equal to 1.66 into 10 raised to minus 27 kilogram. So 1 atomic mass unit or 1 unified mass, that is equal to 1.66 into 10 raised to minus 27 kilogram. Clear? So it's clear, children? So here, this carbon with atomic number 6 and mass number 12. It is taken as the standard reference. So the relative atomic masses of all elements have been found with respect to an atom of carbon 12. Okay. Have you completed?
Yes, ma'am.
No, ma'am.
Okay, fine. Amaljit, can you please read?
Yes, ma'am. In the 1961, IUPAC have accepted atomic mass unit U as carbon-12 isotope was chosen as standard reference for measuring atomic masses.
Yes.
The atomic mass unit is defined as the quantity of mass equal to 1/12 of the mass of an atom of carbon-12. 1 AMU or U is equal to 1/12 into mass of an atom of carbon-12. 1 U is equal to 1.66 into 10 raised to negative 27 kilogram.
Yes.
The relative atomic masses of all elements have been found with respect of an atom of carbon-12.
Okay. Have you completed?
Yes, ma'am.
All of you?
Yes, ma'am.
Okay. So here nowadays we are using this carbon-12 isotope as the standard reference for measuring atomic masses. Okay. And this 1 AMU or 1 U, that is equal to 1.66 into 10 raised to minus 27 kilogram. Clear, children? Shall I move to next slide?
Yes, ma'am.
Yes. Then now we are going to learn the atomic masses of few elements. Okay, atomic masses of few elements. So these are the atomic masses of elements that can be find out using carbon-12 isotope as the reference. Okay, scientists took the reference as this carbon-12 and find out the atomic masses of all other elements. So you have to learn the atomic masses of the elements given in your textbook. Okay, we can write it one by one. It is very useful for writing the molecular formula, etc. in the next section. Okay, so you have to always remember the atomic masses of these elements. So we can write it one by one. First, we can write hydrogen. Hydrogen. So you can write the heading atomic masses of elements. Atomic masses of elements. Just wait. Okay. So first we are starting with H. What is H?
Hydrogen.
H, hydrogen. So its atomic mass is 1. Hydrogen, its atomic mass is 1. What about the unit of atomic mass?
U.
U. U stands for? U stands for? U for? Yeah, it's unified mass. Okay, U stands for unified mass. We can also write AMU, that is atomic mass unit. Okay, so hydrogen, it's 1. Then next one is C. C for?
Carbon.
Carbon. Its atomic mass is 12. That's the reference, right? Carbon, it's 12. Then the third one, that is nitrogen. Nitrogen, its atomic mass is 14. 14. Then fourth one, oxygen. its atomic mass is 16. Oxygen, its atomic mass is 16. The next one is sodium. What about the symbol of sodium?
Na.
It's from which word?
Natrium.
Natrium. Okay. Sodium, its atomic mass is 23. Okay, 23. The next one is magnesium, Mg. Its atomic mass is 24. 24. Seventh one is sulfur. Its atomic mass is 32. 32. Next one is chlorine. Chlorine. Its atomic mass is 35.5. Ninth one, calcium. Its atomic mass is 40. So these are the atomic masses of few elements in the periodic table. You have to thoroughly learn this atomic mass, because after learning this atomic mass, you will learn how to find out the molecular mass. Okay, in the case of a molecule, it's just the sum of the atomic masses of element. So first of all, you have to learn the atomic masses of elements. This is the base of all the remaining things that we are going to learn. So first we learn the names of different elements, symbols of elements. Then the third step, atomic masses of these elements. Then the next step, you will learn molecular mass. Then you will learn how to derive a molecular formula. Then you will write chemical equation. So the base of all this, you have to learn the symbols and atomic masses of the elements. Clear, children? Is this clear?
Yes, ma'am.
Yes. So
Yes,
Lynette,
ma'am.
can you please read the names of the elements and its atomic mass?
Hydrogen,
Mm.
atomic mass 1.
Yeah.
Carbon, atomic mass 12. Nitrogen, atomic mass 14. Oxygen, atomic mass 16. Sodium, atomic mass 23. Magnesium, atomic mass 24.
Mm.
Sulfur, atomic mass 32. Chlorine, atomic mass 35.5.
Mm.
Calcium, atomic mass 40.
Okay. 40. Then Hira, can you please repeat it once again? Any issue there? Can't unmute, right? It's okay. Suryadev, can you please read?
H is equal to 1.
H for?
Hydrogen.
Yeah, hydrogen 1. Then hydrogen 1. Yes.
C is equal to 12.
C for?
Carbon.
Yeah. Next one.
Nitrogen is equal to 14.
Then?
Oxygen is equal to 16.
Mm.
Sodium is equal to 23.
Mm.
Magnesium is equal to 24.
Yeah.
Uh,
S for?
yes, sulfur is equal to 32.
Yeah.
Uranium, ma'am,
Cl, Cl.
Cl, chlorine is equal to 35.5.
Mm.
Uh,
Ca for?
CF4.
Mm. Yeah, Ca for? When we unmute the Alan's mic, you will hear a song with calcium, right? Yeah, Ca for calcium, because he is repeating the same calcium, 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 like that. Okay, so Ca for calcium. Clear, children?
Ma'am,
Yeah, Hira.
No.
Now it's
no,
yeah. Now you can read.
ma'am, hydrogen atomic mass 1,
Mm.
carbon atomic mass 12,
Mm.
nitrogen atomic mass 14,
Mm.
oxygen atomic mass 16,
Yes.
sodium atomic mass 23,
Mm.
magnesium atomic mass 24,
Yeah.
sulfur atomic mass 32,
Mm.
then chlorine atomic mass 35.5,
Yes.
calcium atomic mass 40.
Okay. So have you completed, children?
Yes, ma'am.
Yes.
Yes, ma'am.
So for the next class, all of you learn the atomic masses of these elements. Okay. You already learned the names of the elements, symbols of the elements. Now you will learn the atomic masses of these elements. Okay. After that, we have to move to molecule. Okay. Molecule. So next class, all of you learned this portion very well. Okay. So let me take your attendance. Just wait. Okay, children. So thank you, everyone. See you in the next class. Bye.
Thank you, ma'am.
Thank you, ma'am. Okay,
Thank
ma'am.
you.
See you, ma'am. See you
Thank
soon.
you.
Bye bye.